Hello my dear children, hope you all are fine over there. Once again welcome to our physics class. In the previous session we had discussed about law of conservation of mechanical energy, and we learned that energy can neither be created nor be destroyed. It can only be converted from one form to another form. Also, the total mechanical energy of a system remains constant always. Okay, even though the individual energy, that is kinetic and potential energy, may change at different points, but the total mechanical energy of a system at any point will be the same. We also proved the same using a simple derivation. So I hope all of you remember that derivation. It's very important. Now today let's move on to the last topic of this chapter, that is power. So all of us do work at the same rate. Is it true? Do all of us work at the same rate? No. Do machines consume or transfer energy at the same rate? Do all the machines consume and transfer energy at the same rate? No. So agents that transfer energy do work at different rates. Okay, so let's understand this from a simple activity. So consider two children, A and B. Okay, the weight of both the children are same, and both of them start climbing up a rope separately. Both reach a height of 8 meters. Okay, so both have started to climb a rope separately and both reach a height of 8 meters. But A takes 15 seconds to reach 8 meter height, while B takes 20 seconds to reach the same 8 meter height. So what is the work done by each? Work done is the same, isn't it? Work done is the same because work done W is equal to force into displacement. So the force is the upward force and the displacement is 8 meters. So both of them has traveled the same distance 8 meters and both of them has applied the same force to climb up the rope. So the work done is same. But A take less time than B to do the work. Isn't it? That is the difference. A takes 15 seconds to reach a height of 8 meters, but at the same time B takes 20 seconds, 5 seconds more than A to reach the same height. So work done is the same, but A has taken less time than B to do the work. So who has done more work in a given time? Who has done more work in a given time? That is, if we consider 1 second. Who has done more work? So work done is same. Suppose the work done by both A and B is 10 Newton. Okay, 10 Newton. So within 15 seconds A has done 10 Newton work. So within 1 second A will do 10 by 15. Similarly, within 20 seconds B has done 10 Newton work. So within 1 second B has done 10 by 20. So who has done more work within 1 second, A or B? Yes, just look at the fraction. Here in the denominator we have 15. Here in the denominator we have 20. So this fraction is more and this fraction is less. So that means A has done more work in a given second or in 1 second than B. So within 15 seconds and 20 seconds A and B has done the same work, 10 Newton. But if we consider the case in 1 second, in 1 second A has done 10 by 15 joule of work, and in 1 second B has done 10 by 20 joule of work. That means A has done more work than B in 1 second. Okay, so that is the difference here. So a stronger person may do certain work in relatively less time. Similarly, a more powerful vehicle would complete a journey in a shorter time than a less powerful one. We talk of the power of machines like motorbikes and motor cars. The speed with which these vehicles change energy or do work is a basis for their classification. So power measures the speed of work done. That is how fast or how slow work is done. That is measured by, or that is expressed by power. So power is defined as the rate of doing work, or it is defined as the rate of transfer of energy. So if power is rate of doing work, we can define power as work divided by time. So if power is rate of transfer of energy, we can also define power as energy by time. So two expressions are there to express power. One is power is equal to work by time. Work by time means rate of doing work. If we divide any quantity by time, we will get rate of that quantity. So here we have divided work by time. So we are left with the rate of work done. If we divide energy by time, we will get the rate of doing or rate of transfer of energy. So two expressions are there for power. One is work divided by time and another one is energy by time. So what if in the case of this example, that means among A and B, who has more power? Yes, power is more for those person who has done the given work within a short period of time, isn't it? So here A has taken only 15 seconds to climb up 8-meter height, but B has taken 20 seconds to climb the same height. So A has done more work, or A has done the work within a short period of time than B. So A is more powerful than B. Okay, so this is power. It helps us to measure how fast or how slow the work is done. So this is power. This is the definition. It is the rate of doing work. Also, what is the expression? Power is equal to work divided by time. Also, power is equal to energy by time. Two expressions are there. And what is the unit of power? So unit of power, SI unit of power is watt. SI unit of power is watt, W. And watt is also known as joule per second. Why? Because power is equal to work by time. Unit of work is joule. Unit of time is second. So work by time is joule per second. Okay, so unit of power is joule per second. And if we consider power as energy by time, then also the unit will be the same, because the unit of energy is joule and unit of time is second. So unit of power will be joule per second. So another name for joule per second is watt. Watt. And this watt is in honor of a scientist, James Watt. And the symbol of watt is capital W. Okay. So what is 1 watt? See, 1 watt is equal to 1 joule by 1 second. Because we know that power P is equal to work divided by time. So if work is equal to 1 joule and if time is equal to 1 second, power P is equal to 1 watt. So 1 watt is equal to 1 joule per second. That means 1 watt is the power of an agent which does work at the rate of 1 joule per second. Again, 1 watt is the power of an agent which does work at the rate of 1 joule per second. Okay, so 1 watt, it's important. 1 watt is the power of an agent which does work at the rate of 1 joule per second. Okay, so 1 watt is 1 joule per second. And another unit of power is 1 kilowatt. Sorry children, this is not K, this is L. Okay, this is L. So another unit of power is kilowatt. Kilowatt is the bigger unit of power. Okay, and 1 kilowatt is 1000 watt, or 1 kilowatt is 1000 joule per second. Okay, so the power of an agent may vary with time. This means that the agent may be doing work at different rates at different intervals of time. Therefore, the concept of average power is useful here because the rate of doing work will be different at different periods of time. So, the concept of average power is useful, and average power is obtained by dividing total energy consumed by total time taken. You know, average speed or average velocity. Average speed is total distance by total time. Average velocity is total displacement by total time. Similarly, average power is equal to total work by total time. Total work by total time. Or average power is equal to total energy consumed by total time. Okay, so this is average power. Average power, the concept of average power is also important. Next, we can move on to the last topic, that is commercial unit of energy. So we all know the unit of energy is joule, right? But this unit joule is too small and hence is inconvenient to express larger quantities of energy. Okay, joule is too small and hence it is inconvenient. That means it is not convenient to express larger quantities of energy. So we use a bigger unit of energy called kilowatt hour. Okay, so what is kilowatt hour? It is the bigger unit of energy, as the unit joule is inconvenient to express bigger quantities of energy. We will use a bigger unit of energy called kilowatt hour. So what is this kilowatt hour? So 1 kilowatt hour is the energy consumed in 1 hour, because 1 hour is very clear from the name. 1 kilowatt hour, that means it is the energy consumed in 1 hour at the rate of 1 kilowatt, and 1 kilowatt is 1000 joule per second, right? So 1 kilowatt hour is the energy consumed in 1 hour at the rate of 1000 joule per second, or 1 kilowatt. And kilowatt hour is also the unit of energy. Joule is also the unit of energy. So we must know the conversion from kilowatt hour to joule. How can we convert a unit in kilowatt hour to joule? So to convert a quantity in kilowatt hour to joule, we need to multiply that quantity with 3.6 into 10 raised to 6 joule. Okay, so how can we arrive at this value 3.6 into 10 raised to 6 joule? So within 2 or 3 steps, we will obtain this value 3.6 into 10 raised to 6 joule. And you must know that small derivation. So just listen here. Just note down this derivation because I am not going to give this derivation in your notes. So just note down. Please be ready with your pen and notebook. You can pause the video, take your pen, notebook and just note down this definition or derivation. Conversion of kilowatt hour to joule. Okay, so you can just give the heading like that. Conversion of kilowatt hour to joule. So we know that 1 kilowatt hour is, 1 kilowatt hour is equal to 1 kilowatt into 1 hour. I hope it's clear. This is the first step. So 1 kilowatt hour is equal to 1 kilowatt into 1 hour. And convert kilowatt to watt, because watt is the SI unit. So 1 kilowatt is 1000 watt. You know that. Equal to 1000 watt into. Hour is not the standard unit of time. So what is the standard unit of time? It is second. So you know 1 hour is 60 into 60 seconds, right? 60 into 60 is 3600 seconds. So 3600 seconds, right? So just multiply these values. So you will get 36, 1, 2, 3, 4, 5 zeros, this much watt second. And what is watt second? In the previous slide we have seen watt second is joule. Watt second is joule. How? See, power P is equal to work divided by time. From this, what is work? Work is equal to power into time. And what is the unit of power? It is watt. What is the unit of time? It is second. So watt second is the unit of work. Okay, or it is the unit of energy. Okay, so watt second is the unit of work, or watt second is the unit of energy, and you know the unit of work or energy is joule. So watt second is equivalent to joule. Okay, so this much watt second or this much joule. Now we can simplify this. See, if we put a decimal here after 3, if you write this as 3.6, then how can you write into 10 raised to, how many decimal places are there after 3? 1, 2, 3, 4, 5, 6. Okay, so 3.6 into 10 raised to 6 watt second, or this will be equivalent to 3.6 into 10 raised to 6 joule, because watt second is joule itself. So 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. So it's a simple derivation. First you just split this value or quantity. 1 kilowatt hour is 1 kilowatt into 1 hour. Then convert kilowatt to watt. Then convert hour to second. Then multiply it. After multiplication, write it in a simplified form using a decimal value, or in the decimal form. Then instead of watt second, you can write joule. Okay, because watt second is equivalent to joule. So this is the conversion unit. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. You must always remember this. So the energy used in households, and industries and commercial establishments are usually expressed in kilowatt hour, because all these are bigger quantities of energy. So the energy used in households, industries and commercial establishments are usually expressed in kilowatt hour. For example, electrical energy used during a month is expressed in terms of units. Okay, so whenever you will get a chance to come across your electricity bill, you can see the term unit in that bill. So what do you mean by units? See, units is kilowatt hour itself, or unit is also another name of kilowatt hour, and 1 kilowatt hour is 1 unit. Okay, 1 kilowatt hour is 1 unit. So if you want, you can take a close look at the electric meter installed in your house, and you can observe its features closely. You can take it as an activity. Take the readings of the electric meter each day at 6:30 a.m. and 6:30 p.m. So how many units are consumed during the daytime? That means from 6:30 a.m. to 6:30 p.m. how many units of electricity are consumed? You can get that by subtracting the values. Okay, and also you can check how many units are used during night time. Do this activity for about a week. Tabulate your observations. Draw inferences from the data. Compare your observations with the details given in your monthly electricity bill. Okay, so the electricity department will charge the electrical energy in terms of units. So you need to pay this much paisa for 1 unit of electrical energy, isn't it? So from the electric meter, you will get an idea of how many units of electrical energy you have consumed in 1 month, and that number of units into cost of 1 unit electrical energy gives you the electricity bill for a month. Suppose 1 unit of electrical energy cost 50 paise, and suppose you have consumed 100 units of electrical energy in 1 month, then what will be your electricity bill? 100 into 50 paise. Okay, 100 into 50 paise, that means 5000 paise, that is 50 rupees. So 50 rupees will be the electricity bill for 1 month. It's just an example. I know 50 rupees in 1 month, it's not possible. You all know that. Okay. So that's all about the commercial unit of electrical energy. So the commercial unit of electrical energy is 1 kilowatt hour, and it is the bigger unit of energy. Usually joule is the unit of energy, but it is not convenient to express larger quantities of energy. So we will go for another unit, that is kilowatt hour. And 1 kilowatt hour is the energy consumed in 1 hour at the rate of 1000 joule per second. And 1 kilowatt hour is 3.6 into 10 raised to 6 joule. This is very important. And 1 kilowatt hour is also termed as 1 unit. Okay. So children, that's all about this chapter. With this I am concluding this chapter, and we will discuss the numericals of this chapter in the next sessions. Then we will meet in the next session. Notes of the topic and YouTube video have been uploaded. Please go through that. All of you stay safe, stay home, keep learning. Thank you.